That means that I've now started recording what's happening on the screen. I'll sometimes forget to do that, and then we'll be stuck. So then we'll be stuck if I forget to do that. We won't have that stuff available to us. So I'll try and organize things by the date of the lecture in this directory. I'm probably going to use the same directory for both sections, so there may be slightly different versions of the code available. And but I'll only do videos from one section. I guess it'll be you guys, so that they're done sooner. Right. So what have we got here? This is my desktop. This is a terminal window. Figure out how to start a terminal on your machine. If you work in a Linux environment, that's easy. There's lots of terminals available, and PowerShell for Windows, and what do you call it under Mac OS? Just terminal. So there you go. Install Python, and when you do, once you do that, you can just fire it up. There you go. So there's Python. We all know about Python now. This tells me the version. Version I have is 2.7.3. What's important there is the 2.7. The 0.3 is not terribly relevant, but what you probably want to avoid for this course, because it can get you in trouble, is installing the most recent version of Python, which is version 3. So the reason you don't want to do that is there's a lot more Python code that's written in version 2.7 than there is in version 3 right now. So if you end up working on a large-scale Python project, it will probably be written in 2.7. And there's a lot of environments where Python 3 is not available yet. And if you learn 2.7, going to 3 is not terribly difficult. But keep in mind, the reason I don't want you to be using 3 is 3 has some features in it that if you use them and then the TAs mark your code and see that they're being used, they'll be using 2.7 to test things, and it may not work for them. So don't do that. Okay, what's the simplest thing we could do in Python? How about we add two numbers together? 2 plus 2. So 4. No surprise there. Okay. Clear what happened there? Slightly more complicated. 2 plus 2 plus 2, 6. 2 plus 2 plus 2 times 2. What's the answer there? 8. Not 12? No. Why not 12? Yeah. So Python does, in most cases, just does the right thing. It's another reason it's a good language to use, is it does what you expect. And in this case, it treats an expression like this using the standard BEDMAS, which is brackets, exponentiation, division, multiplication, addition, and subtraction rules. And so this 2 plus 2 times 2 is really the same thing as if we first did the multiplication of those 2's and then added the other 2 in. So 4 plus 2 plus 2. That's interesting. How about this? Anybody know what that is? Yeah. So this is 2 to the power 3. So that's 2 times 2 times 2. So in Python, there's exponentiation. That's something that you probably didn't have in the first language that you used. Here's something somewhat surprising about Python. So what's the answer here? A big number. Number with a lot of digits. And how about 2 to the 2000? Another number with a lot of digits. So if you're a little bit more than a novice programmer in a traditional programming language, then this might be a bit surprising to you, because in most programming environments, the integer 2 to the power 2000 is just not representable. It's too big. Python does, like I said, it usually does the right thing. And so when numbers get really big, or integers get really big, it represents them in a way that nothing is lost. It's really, this is the decimal expansion of 2 to the 2000. And you can see what I mean by really, really big. When this happens, it'll print those numbers by, or it'll, when you display those numbers in the interpreter, it puts a little L on the end to let you know that this is somehow special. These are, this is a bigger number than usual. So we didn't get that when we did 2 to the power 3. We just had a regular old integer. But 2 to the 120 was already one of these, what they call long integers. Okay. All right. How about what's that? -2. So it's 2 minus 2 minus 2. There you go. And what about that? There you go, 0. So it does things that are in the same same level of precedence. It just does them left to right. All right, that's good. Anybody? People have done this before. This kind of pseudo programming before. Yeah.
Just clarifying that I'm catching all that you're doing.
Yep. So we're just working in what's called the interactive mode of Python, putting in simple expressions, and typing in a simple expression like 2 plus 2 and hitting enter just gives you the answer 4.
So everything you are typing is everything you are saying. So
yeah. Yeah.
Is it used like strings to show that answer, or some sort of array?
Right now, all you're seeing is the result of evaluating that expression, and it's showing it to you in some way that's useful to a programmer. So it's not it's showing you the value of that expression, which is 2 plus 2 is the value of that is 4. 2 to the power of 2000. You don't have to worry about how that's implemented, but essentially it's an array of integers. Yeah. So it just keeps adding bits, enough bits to represent the number that it needs to. Okay. So that's good. Let's do something that looks a little bit more like a program. Right now this just looks like a calculator. So let's open up a text editor. So we'll open up a text editor with a file called september06.py. The .py extension is the standard for Python programs. And let's do something like calculate the area of a triangle. Something really simple. So let me open up. So if I have a triangle, and there's lots of ways to represent a triangle, but one, if you're just interested in things like area, is through a length on the base and another length called the height of the triangle. And so if those are the two parameters that represent your triangle, then what is its area? Yeah, it's half, just a second, what was that called? It's half the base times the height. So we want to implement something simple like this, a function that computes the area of a triangle. So let's do that. Well, we want to define a function, so we use the def keyword, and we'll give it a name, area of triangle, and it takes, there's two parameters, the base and the height. And well, what we would like this to do is return the base times the height divided by 2. Half the base times the height. Okay. So we'll fire up Python. We'll have it load this file, and this -i here tells it to enter interactive mode, because right now this is just a function. If we just load this file, it won't do anything. If we just run this file, it won't do anything. So we'll go into interactive mode after reading that file. Now we've defined this thing, and let's say the base is 4 and the height is 4. What should the area be? 8. 4 times 4 divided by 2, that's 16 divided by 2 is 8. And indeed, it gives us the right answer. Okay. Let's try an even simpler one. If the base is 1 and the height is 2, what's the area? 1. And if the base is, well, let's see. If the base is 1 and the height is 1, what's the area? 1 times 1 divided by 2 is half. This says 0. Yep. Let's see. Yep. So, some of you seem to have recognized what happened here. And so what's the issue? Yeah. Yeah. So there's a difference in Python and in every other programming language. There's a big difference between integers, these whole numbers, and these things that are not integers, numbers but not integers. These fractional numbers, they're sometimes called floating point numbers. There's a big difference in the way these things get treated. And actually, well, Python is a newish language and still evolving. And one thing that happened semi-recently in the development of Python is they realized they made a mistake when creating this language, that they shouldn't be, remember I said Python usually does the right thing. Well, in this case, it's not doing the right thing. This is not what you expect, right? 1 divided by 2, the answer is not 0 in any reasonable mathematical sense. It's just some convenient answer for integer calculations on computers. So they realized they made a mistake in the definition of the language, and so they updated it. Now the problem with programming languages is people write code in programming languages, and that code expects the language to work in a certain way. And if you go and change the language from underneath them, then their code stops working. And that's really not allowed. And so when you change the language, you somehow have to allow people to use, or by default, people should use the old version of the language, and you have a different way of using the new version. And this actually comes up in Python. There's two things that we'll see here. So these, you can read about this, the Python division semantics. For us, what we actually want is the new way of doing this. We'll see two ways of getting this. So one is on the command line, you can tell it that you want Python, and for taking quotients, I want the new way of doing it. When I take it the new way, and I ask what's 1 divided by 2, I get 0.5. When I ask for the area of a triangle with base 1 and height 1, I get 0.5, the things you would expect. So this is an important thing, and one that can trip you up on assignments. If you want this to happen without having to specify it on the command line, there's a sort of awkward thing you include in your file, and you should probably include this in the top of every file that you write, which is tell Python, go to the future and import the right kind of division. It's the way you can think about that for now. This will then do division the way you expect it to do. 3 divided by 2 is 1.5, not 1. Okay, does anybody see any, I don't know, problems with this, potential problems with this? Yeah?
How would you do this on a Mac? Just do the same thing on a Mac.
Do what on a Mac?
It does the same thing, but like, when I'm trying to push it in, like, it's getting some errors.
Which parts? Where you're getting errors from what?
Like, just even the beginning, like, I was trying to do the same thing, I don't know.
So, what is the error message? That's
It's just saying bash, and this, and then I turn it on, it just tells me like bash something.
okay. So when you type Python, what happens?
It just says like it's compatible with Apple type and Java type.
Okay. And when you type 2 plus 2, what happens? Yeah, it's working. Yeah. So notice a couple of things. This is the terminal. Here I'm seeing, you'll see different things depending on where you're working, but it's usually just telling you what directory you're in, as well as maybe the name of your machine and so on. That really depends on how things are set up. But there's a difference between being that and being in the Python interactive mode, which is this. That you can usually recognize, well, because there's this header at the top and you get these triple greater than signs. So know which one you're in. You can't just enter Python stuff at the terminal. You have to be in the Python interpreter. Okay. All right. We'll come back to this integer division stuff shortly. But for now, we'll always want to run with -q new. All right. So we've seen how to make a function that takes some, these two parameters and returns some value that's computed using these two things. What's another big basic thing in programming languages? Functions is one of them. Not before strings, but what's that? Arrays. Yeah, arrays are going to be the topic of next class. Classes, that's getting really advanced. Modules, methods, really think back more fundamental than that. Well, variables, there you go. There's the answer that I'm looking for. So if I want to do something like, write a function that computes, well, let's say the area of a circle. So let's do that. Define area of circle. So it's enough to know the radius of a circle to compute its area, right? And what is the area of a circle? In terms of its radius?
Pi r squared.
Pi r squared. Okay. So there's r squared. But what about this pi thing? Okay, there's pi. So pi times r squared. So let's load that up. Okay, seems to have loaded okay. So let's find out the area of a circle of radius 1. So we get an error. And you're going to see lots of these things. You get this traceback, most recent call. It tells you something about the file where it found an error. Standard in because somehow I was working, I was writing. And then it tells me actually it was inside this file here, September 06, line 7, in a function called area of circle. There's an error. There's the line that's causing the error. It's a name error, and it's telling me that this name pi is not defined. So there should be, what I wanted was this pi to mean something, but it's not defined. So we can do one workaround for that. What's pi? Something like that. Yeah, 363, 263. Okay, so we can do that instead. And let's say, okay, good. So a circle of radius 1 has area pi. Circle of radius 2 has area 12.566. Looks right. 3 looks right. So that's great. That seems to work, except there's a couple of problems. One is I don't like the way this code looks for a couple of reasons. We all happen to know what pi is. Is this the value of pi? No. This is some rough approximation to the value of pi. So that's a problem. And, you know, if I was a total novice, I might look at this number and say, well, so either if I knew very little about mathematics or I was very rigorous about mathematics, I would say, well, I don't know what this number is. The number doesn't mean anything. It's not pi. It's not anything. So I don't understand what this code is trying to do. So it would be maybe a little bit more useful if we just defined a pi. Then the code is a little bit more readable. You can see what's being returned. It's something that's called pi times r squared, and pi we define it to be this reasonably close approximation. Yeah.
So does that automatically assume that that's an integer again, or like what type of variable would it be? How do we do variable variance?
So this is one of the nice things about Python is the way you declare a variable is you assign to it. So this line here is the declaration of the variable and its initial assignment. So you don't have to do anything fancy. You don't have to declare it somewhere else first. You just assign a value to it.
So if you put a value in it, and let's say it declares it one way, an integer, but you want to put a decimal in it later, it's going to screw up, right?
Nope.
Oh, it'll autocorrect?
So let's try. Pi is equal to 3.1415 something. We can look at pi. Well, I changed my mind. Pi is equal to 3. No problem. Pi equals s. Then it tells me it doesn't know what s is. Strings are different. Well, no, not different. It's saying you're trying to assign this value s to pi, but I don't know what s is. I can say s equals pi. That works. Now I can look at s and I can look at pi. They're both the same. But what's on the left-hand side of an assignment is the thing that's being defined, and what's on the right-hand side should already be defined. Yeah.
I think what he's trying to say might be something like pi equals quote s.
Yeah, I think you're asking something like this. Yeah, so there's no problem changing the type of a variable. Variables don't really have types. There's just something that's assigned to them that has a type, and you can change it. There's no problem with that. Yep.
How can you just change the variable? Why isn't it just always y? When I run something, put some Java, I just change the variable.
Well, that's the nice thing about Python is it's an interactive language, and it's a dynamic language. You can do when you're running in interactive mode like this, you can change the value of anything. In particular, so we imported this file with these functions in there, and let's say I don't like this this area of triangle function. I can just say that it's equal to 5. There. What's area of triangle now? It's 5. It's not a function anymore even. Yeah.
So now that you've changed the value of pi to a string, what if you tried to run area of circle on it?
Well, that's not going to be a problem because area of circle defines its own value of pi just before it uses it.
So it'll redefine it.
Yes. Yeah.
And then if you try, and then if you hold the value of pi again afterwards, it would give you the number?
No, but I don't want to get into why just yet. This is a local variable to this function. In case there's the short answer, but many people won't know what that means. So, yeah. Okay. So a little bit about this idea of integers and not integers. So we saw that you can do things like take an integer to a big power, and you get this really big, long integer. But then there's these other things that are not integers. We'll call them floats. And the way you write those is you just put a decimal point in your number somewhere. That's the easiest way to do it. And then something different happens. You get this thing which is not an integer anymore. It's this floating point. And this one is, they can also represent big numbers, but they do it in a weird way that you don't get all of the details. It says that this number is about 4.660, so on, times 10 to the power 78. So it's not exactly the same as this number. It's just a rough approximation. So if you stick to working with integers, you'll get exact values. But as soon as you do something like use even one floating point number, everything will become floating point. You'll have lost a value, or if you do a division, which is not an integer value, you'll lose. Well, if you do a division, you'll lose it then as well. Yeah. So the new division doesn't do that. So new division says when you do division, what I'll give you back is a floating point number, even if you're dividing two integers. Yeah, so I get that. I get a finite number of 0.3s.
Is it always the same number of decimals?
So what you're seeing here is not necessarily exactly the number that's represented. It's just what it wants to display to you of that number. In fact, the number that's represented is something that's represented in binary floating point notation. So it's actually something that also can't necessarily be displayed using decimal numbers. Okay. All right. So that's fine, and this is usually what you want, and these new division semantics prevent a lot of errors, like in this area of triangle calculation, with the old division semantics, you can test this and it looks like it works for a little while until you accidentally give it integers, and then the division isn't right. And so they got rid of that, but there's times, in fact there's lots and lots of times, when what you really want is integer division. And so they kept that, but you have to ask for it explicitly. So 3 divided by 2 is 1.5, but 3, and you pronounce this as div 2, that's 1. So So this is real integer division. So notice there's even a difference if I take 4 divided by 2, I get 2.0, and if I take 4 div 2, I get 2, the integer. So it's something you always have to keep in mind is the number that you're working with. Do you really want it to be an integer? If so, you have to take some special care when you do things like division, or do you not care about that and you really want it to somehow represent the, fractions as well? In which case you just use the normal operations. Okay. So let's just do an example. What is 13 div 4? 3. And that's because 13 divided by 4 is 3 1/4, and when you do integer division, you just drop the fractional part. So we drop the 0.25. So that's good. That tells us what the integer part of the division is, 3. What if we want the leftover? What if we want the remainder? Yep. Yeah. So the companion to the div operator is the mod operator. That's at the same level of precedence as div. So now there's basically multiplication, division, div, and now there's this new one, mod, that are all somehow at the same level. And what's 13 mod 4 then? Yeah. So 13 divided by 4 is 3, and the remainder is 1. So you can extract these two parts, the integer part and the remainder part. The integer part you get with div, and the remainder you get with this mod operator. So let's see what we can do with these two things. So here's a situation that you can try out at home. How many of you have microwave ovens where you're living? Okay. And normally you press a button that says cook, or maybe you just put in a time and press start. What happens if you press 100 and press start on your microwave? You get 1 minute. What happens if you press 90? Okay, so 100 on a microwave is smaller than 90, right? 100 is 60 seconds, and 90 is actually 90 seconds. So there's something funny going on there. You should try the 90 thing. Does your microwave count back from 90, or does it count back from 1:30? Anybody know? Anybody tried it? Yeah?
It's 1:30.
Depends on the implementation of your microwave. Some of them will immediately switch to 1 minute 30-second format. Others will just count down from 90. But let's think about a little bit about how this kind of stuff might work. So let's say I was implementing this display on a microwave, and internally it makes a lot of sense for simplicity to represent the cooking time in seconds. So if you're the microwave and you're counting down, it's a lot easier to count down from 90 down to 0 than it is to count down from 1 minute 30 down to 0, because once the 30 goes to 0, then you've got to flip the 1 and so on. On the other hand, the person who's looking at this likes to see how many minutes are left, so they prefer to see a display that splits it up into minutes and seconds. So let's say we want to write a function that takes seconds and converts them to minutes and seconds. So I'll give it a time, s in seconds, and it should tell me how many minutes that is and then how many seconds that is. So So how many minutes are there in S seconds? Yeah, so S divided by 60, div 60. So S div 60, that should give me the number of minutes. And then what's the other part? S mod 60. That should give me the number of seconds. So here's something that may be surprising to you also. So what am I doing here? I'm returning two things. Many languages don't let you do that, but Python lets you do lots of great things. So let's load that up again and ask for seconds to min seconds. Let's see what it does with 90 seconds. What did I get wrong? Aha. Good eye. So I mistyped the name of the function I was calling. I missed an S. This kind of typo is the source of a lot of errors. Get quick at spotting them. So the most important thing to do when there's an error is to just sit there and carefully read everything that it's telling you. Once you do this for a while, you'll be able to read these almost instantly. But in this case, I did something that I thought should be not problematic at all. It raised an error. It says the most important part of this error message tells me where it was. It's line 1 and on the input, standard in. And it tells me that this name is not defined. And then for these kinds of errors, you really have to put on your careful reading glasses and see what the typo is. Okay, so what's this going to give me? So 1 comma 30. So it gives me this pair, which is 90 divided by 60 gives me 1, or div 60 gives me 1, and 90 mod 60 gives me the 30-second remainder. And 900, anybody know that? 15 minutes. 3,600 seconds. Yeah. 60 minutes, 0 seconds. So, well, we might as well take this one step further. 60 minutes is not something you like to see. If you're implementing that's the display, maybe not on a microwave, but on a real oven, well, they have cook times that go into hours. And I'm not liking this name. I'm really fond of short names because I make a lot of typos. So let's write a function called seconds to hours, minutes, seconds. So someone gives me a number of seconds, S, and I want to figure out 3 things. How many hours, how many minutes, and how many seconds. So how do I figure out how many hours there are? Yeah, so there's 3,600 seconds in an hour. So the number of hours is going to be the number of seconds div 3,600. Now how many minutes are there? Well, let's see. And how many seconds? We've done this one before. Yeah. Notice I'm redefining the input here. That's fine. As long as this input parameter S, I'm redefining it here. There's no problem with that as long as I don't want to use the original value anymore. And I'll return this triple, hours, minutes, seconds. So, is that going to work?
No.
So can someone, well, let's test it. Some people really say no. Some people say, anybody say yes? So seconds to hours, minutes, seconds. Let's try 63 seconds. So that's 0 hours, 1 minute, 3 seconds. So far, so good. Let's try 95 seconds. 0 hours, 1 minute, 35 seconds. Let's try 900 seconds. That's 15 minutes, 0 hours, 15 minutes, 0 seconds. Looks good, right? Yes? Anything we missed in our testing? Okay. Let's try one that we know the answer to. 3600. Uh-oh. 3600 says it's 1 hour, 60 minutes, and 0 seconds. So what's the problem there? Yep.
On the minutes, we have to take the remainder of what you have from the hours and then divide it.
Yeah. So here we figured out how many hours we had by dividing by 3600. And then we figured out how many minutes we had by dividing by 60. But we never took care of the fact that there's a whole bunch of seconds that we used up for those hours, right? So how do I resolve that? How do I fix that? Yep.
Subtract the value of h from s to 60.
So you say take s and subtract the value of h, or
Wait,
let's
no,
say
when you're calculating the number of minutes, subtract the value of h from that value.
like that.
Times 60. Yeah.
That'll do it. So there's one way to do it. Let's just check that it works. So 1 hour, 0 minutes, 0 seconds, and if we go to, we get 1 hour, 1 minute, 35 seconds. That works. So here, when calculating the minutes, we want to get rid of the number of seconds that we just got rid of. Any other ways to do that? Yep. Yeah. So once we've figured out how many hours there are, well, after that, we don't care about those anymore. So we just take them away. So anything that's a multiple of 3600, that's taken care of in the hours. What we want left is the remainder after you take away all the multiples of 3600. So this does it too. And if you wanted to go from here to milliseconds, to microseconds, to nanoseconds, you'd keep doing this. Next time it's going to be mod 1 and then div 1000 and so on. Div, yeah. So you can take this further, but that's enough for that. Okay. So last thing then I would just like to point out is Python has libraries, and one of the useful ones is the math library. It's useful for the things that we want to do. And the way you get things out of, so there's a lot built into the Python libraries, and the way you get to use things in the Python libraries is you import them. And we've seen this before. So for example, if I want to take square roots, I can say, from the math library, import the square root function. Now I can ask for things like the square root of 5, the square root of 2, and so on. If I want to do logarithms. You guys know what logarithms are? Yeah. So now I can ask for things, you know, what's the base 2 logarithm of 5? What's the base 2 logarithm of 8? What's the logarithm of 10? All of those things. So all of the usual functions you can import this way: square roots, sine, cosine, these trig functions. And there's a couple of other useful things that are not functions. You can import pi. So from math, you can import this variable that's called pi. Now you get to use it. You don't have to keep defining it yourself. Yep.
But if you want to import all of math,
That is, well, then you can say import math. But now, every time you want to use something in there, you have to say, for example, math.pi. So not just pi, but so for example, that doesn't import the sine method. If you want the sine method, now you have to say math.sine. In general, so there is actually a syntax for importing everything, but it's usually a bad idea. Just import the stuff you need, because there's a lot of libraries, and there's not a lot of nice ways to name functions or variables. And so if you just import a lot of stuff from different libraries, there's a good chance you're going to have a collision in the names. And so that's probably not what you wanted. Real quick now, there's some other operators that you may not be used to, and these are the comparison operators. So 1 less than 2, what does that evaluate to?
1 or 0.
True. 1 bigger than 2, that evaluates to false. 1 less than or equal to 2, true. What about 2 less than or equal to 2? Okay, good. It's good that you know the answer to that. It means you know what or means. Not everybody does. Okay, so there's these comparison operators, and what you want to know is where these things fit in. So we saw that stuff works on using BEDMAS rules, but BEDMAS doesn't talk about comparisons. So where do the comparisons go in there? Let's find out. So this is either going to work or it's not. Is it going to work? So it evaluates to true. In particular, it works. So that means it didn't do this. Right. What it did was added 2 and 2 together, got the answer 4, and said, checked if that's less than 45.
What would happen if it was like the other way of brackets around? What happens
So what's that going to do?
Oh, because true is 1.
Yeah. So true is somehow synonymous with 1. So if you say, 4 plus true, you're really saying 4 plus 1. 4 plus false. Now, again, it does the right thing. If you say, is 2 plus 2 less than 45, or 2 plus 2 less than 45, certainly, almost surely what you meant to ask is this number on the left less than this number on the right? So it's doing the right thing. And so these comparison operators have a level of precedence which is lower than any of the arithmetic operators. So put one of these in there, everything on the left-hand side will get evaluated Everything on the right-hand side will get evaluated, and then it'll ask if the two results are, one is less than the other. Yep.
Where do div and mod fall into BEDMAS?
Div and mod fall right in the same category as division and multiplication. Okay, so so that's all I have to tell you for today, except to check the See You Learn on Monday. The assignment will appear there, and you already know what you need to do about half the assignment. So you can get that done before the next class even.